2 sessions in Munich, and hopefully also with your inspirations, there are more to come. And thank you also to Marcus, who is kind of coordinating the live stream out to the world. Thank you very much.
Thank you. Also from my side, welcome. I'm really happy to see you all, despite the weather conditions. Really happy that AC works in here. So yeah, as Albert already said, my name is Sebastian. I'm a solution architect here at BOOXWARE. My team and I were working on, well, we're using Cloud Foundry to implement the Platform-as-a-Service. And today I want to talk about that, what Platform-as-a-Service actually is, what Cloud Foundry is. So just a little bit of background. I worked as an engineer for quite a while in product development at IBM. I worked on basically automation quite a lot in terms of appliances. So basically where you combine software and hardware and just ship it. So it sort of has the same values as cloud, where you just use something and it simply works. And in my last project, I ended up doing software as a service based on Platform as a Service, and this is really where I got in contact with Platform as a Service and where I fell in love with it. And I want to tell you a bit about why I think it's so super exciting. When we created the meetup description like 2 months ago, I told the guys, okay, yeah, we can talk about like what Platform as a Service is, what Foundry is, how it influences microservices, how they can benefit from that, how this whole thing plays into DevOps, and why we do this here at BOOXWARE. So when I was thinking about preparing the talk, actually, I came up with yet another buzzword, which is as a service. So I want to talk about the why, like why do we end up with platform, or why is platform a cool thing, which is as a service, microservice, and DevOps. Talk a bit about the definition of platform, and then on to Cloud Foundry and Bosch. So first thing, as a service. Usually in commercial software, we create a software, we try to sell it, this generates some money, and then we probably come up with maintenance contracts so we can, our customers get security updates, patches, these kind of things. But usually they don't get that many features because we're putting all these new features into the next release to sell it to our customers yet again. And this leads to a weird thing because we are really interested in constantly outgrowing our user base, which in other words means new customers are more important than existing customers. And all our new killer features are put into the next release, while Agile says, well, we have a new feature, we can bring it, we can roll it out all the time. But that doesn't seem to work in product development, where we hold them back for the next release. So doesn't Agile work in product development? And also for the producer, it's a pain in the neck because they have to maintain various versions over a long period of time. So when we look at as a service things, they usually have a subscription licensing model. And this gets us into a really interesting dynamic between the provider and the consumer. The provider can actually leverage their existing customer base. So there's less pressure on growing their user base. They don't have to sell to new people, they can just sell it to existing customers. And this gives them a continuous revenue stream, and they get a subscription on a monthly basis, on a yearly basis. And they don't have these spikes with new releases anymore, which is just less risk from an economic perspective. But the most interesting thing is there's a shift in goals. It's not about bringing new killer features into the next release anymore. It's about overall customer satisfaction. And this is good for the consumer. So this also means new features, of course, for those sort of things like availability, stability, performance support, all these kind of things which make it nice to use the software. For the consumer, because of the flexible pricing, it's less risk to buy into the software. If it's just, I don't know, $100 a month, we can just jump in, try it out, see if it works. If it doesn't work, we can just move on to the next. We can upgrade on demand. I don't have to buy like tens of thousands of licenses for my office thing. I can just, upgrade whenever I have more employees. And think the most important thing, like outsourcing, generally speaking, is a good idea because it lets you focus on your core business. Okay, so as a summary, we have decreased economic risk on both sides. We have a shift in goal to increase customer satisfaction, and we have the outsourcing, which allows us to focus on core business. Moving on to the next buzzword with microservices. So, microservices, the definition is pretty much agreed. When you go to Wikipedia, it says, or it tells us about the benefits of microservices. So the benefit of decomposing an application into different smaller services is that it improves modularity and makes the application easier to understand, develop, and test. It also parallelizes development by enabling small autonomous teams to develop, deploy, and scale their respective services independently. Let's take a closer look at these claims. So why microservices make everything easier to understand, develop, and test? So the opposite of microservice is the monolith, where everything is cranked up into one thing. And many people are different, or are interested in different things. So we have like the Scrum handling our things, which leads to merge conflicts, deployment scheduling is like, yeah, we want to get this feature out into production. The other guys say, no, but well, our part is kind of shaky. Sometimes you have scaling issues where you just want to scale this one thing, but that means you need tons of capacity because you can just scale by, I don't know, 24 gigabits per second. And also you have tight coupling, which leads to either fragility or rigidity because you're afraid of the fragility. So the idea is we take all these features, all these different interests, and put them into units of their own. And this is nice because they are small and domain specific, which also gives us a means to manage Conway's law. It's strong modularization because you have explicit interfaces, not like, oh, there is a function, let's just use that. It's strong modularization. Okay. So this really ensures that nobody is using interfaces that they should not because they're explicit. And microservices are usually loosely coupled. You use stateless protocols such as HTTP or message queues, which really allows you to use independent technology stacks for all these different things. Like, for example, for this one thing, Java is really good, for the other thing, Node.js is better. Might be, or like you have skills in that team. You can independently deploy them and independently scale them. So this together makes it easier to understand and test them. There are overall less things to consider. There's less coordination. You don't need to talk to all the other teams, like, can you do this? And and you can test them in isolation because you have these explicitly defined interfaces and you can write mobs and stuff for everything. Okay, let's take a look at the second sentence of this claim. Why and how do microservices parallelize development? Well, yet again, we have independent technology stacks, they are independently deployable and scalable, so we can just treat them independently from each other, which allows us to scale them or to develop them. So developing, deploying, and scaling them independently seems to be the trick. But there is a but here, and that is who actually maintains these technology stacks and who actually deploys the microservices and who actually decides what to scale and when. And if your organization looks kind of like that, and Ops was a bottleneck before, then Ops is still a bottleneck. And in that scenario, microservices even aggravate the situation. Things would get even worse. So coming back to this is easily overread. Small autonomous teams are enabled to do this stuff in parallel. Which of course brings us to the next buzzword, which is DevOps. So my ex-boss went to a conference, and he basically, after the conference, I asked him, like, okay, what did you learn? So he said, it was interesting to see that while everyone agrees DevOps is a thing and should be done, everyone struggles at actually implementing that. Which I can relate. Looking at the definition of microservices was kind of easy, but the definition of DevOps, well, there is not that one definition, but it kind of converges around mindset, culture, practices, communication, collaboration, automation, work together, tool chain, efficiency, quality, ownership, not throwing things over the wall, and responsibility. And yeah, so responsibility is a big thing, and most of the time when there is something new in organizations, they just adopt the new terminology, but there's no real change. So nowadays we just say we're all in the same boat. We improve communication and we improve collaboration, and then things will get better. But actually, most of the time there is no change. We were just talking with microservices about autonomous teams parallelizing ready delivery, because developing is just not enough. If you can't get it out of the door, you're not creating value. And we wanted to coordinate less. So what is all this improving communication, improving collaboration? So I give you my personal take on DevOps. Communication and collaboration are seriously misunderstood. It's not about the handoffs between the teams. It's not that we improve communication between the teams. It's about communication and collaboration within the teams. So basically, if you have this kind of organization and all these, we are all in the same boat and improve communication, blah, 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 still end up in handoffs. And they simply do not scale. You have tons of teams on one side and just very few people over here. And on the local level, these teams do not share the goals and priorities. Because for them, the most important thing is to get their feature into production. And for them, it's like, tons of things like that. So hold that thought. And now I want to look at this from a different perspective. Who did test-driven development? Okay, a few hands. So I did it. And it was interesting to see what happened, because usually I was writing my code, I was trying to test, I was struggling with the testing, and I redid all of the tests 1,000 times. I was always feeling like, oh, I already did this, but on a different layer, and it's kind of weird. But when I started using test-driven development, I was exposed to my own code very early in the stage, and I found it not testable, and then I was applying clean code principles and dependency injection to use mocks, and everything was very nice, and all of a sudden I created better code as a side effect, just because I was making my code testable, which means it was strong coherence, it was loosely coupled. So this is what I think, test-driven development creates better code. It's motivation through pain. I was, this painful code led me to write better code. In operations, we often see something similar. They struggle with harsh operating code because there are assumptions made, there are hard-coded values, things are not scalable, or the one thing is scalable, but the back end is not, and all these kind of things. And sometimes they are bad at missing logs, monitoring. And now here's the question: what would developers do if they were exposed to hard-to-operate code? And I claim that developers operating their own code would make their own code easy to operate. It's just motivation through pain. And then, on the other hand, engineering teams need to operate their code themselves, but that helps to scale. So let's take this seriously. What do we need for developers to be responsible for writing this production? So we want to take this organization and turn it over to that. So the teams need to know all the layers to bring value to the customer. They need to know about their software, the runtime, the operating system, which machine, servers, network, storage, all that stuff. But at the same time, since they should also only be responsible for their own microservice, they need to be isolated from each other. How can team A be responsible for something if team B can, just kill their processes or their resources or whatever? And resources should be shared. So it's kind of challenging to get this all at once. All right, so teams, looking at this, like, who knows that guy who knows all of that? It's kind of hard to find. So the teams, generally speaking, need too many skills, and we need a way to outsource all of these aspects. So, as I said earlier, outsourcing is generally a good question. So we basically kind of want to have this where these guys deliver value and they take care of something, they take care of something else, so everybody has just a smaller subset of things to consider, to care about, to be responsible for. But as we just found out, people do not scale. But scales, though, are self-service systems. When you look at sort of a pack station or an ATM, even a vending machine, you can just, build up 5 vending machines and you can serve 5 customers simultaneously. And if you take that to computers, it's really nice because things like Spotify, Amazon, Netflix don't have that many employees but can serve billions of customers at the same time. So we can turn this organization into that. And this is really where we need to start talking about platform as a service. We have the software people who are using a self-service system, which is maintained by other people, and they all have different kinds of responsibilities. Like domain-specific software runs an operating system, hardware virtualization. So, platform as a service. When I started in this company, it was kind of hard to find somebody who understood what platform is. And I always thought that's why, because platform is really ill-defined. But, oh, I'm sorry. Quick recap. We have as a service, which suggests that focusing on your core business is kind of cool. Microservice increase operational complexity, and to do that properly, we need to take care about a few things. And DevOps requires a self-service system to scale. So back to the ill definition, which is actually not ill. It's well defined. The US Department of Commerce entertains a whole bunch of people who come together and call themselves the National Institute of Standards and Technology to come up with definitions. The special publication 800-145, also known as the NIST definition of cloud computing, is 7 pages long and interesting stuff. So they define cloud computing, they attack it from very different angles. They basically say every cloud offering has these essential characteristics, which are on-demand self-service, so you can do it yourself, you can do whatever you want. Broad network access, which is given. Resource pooling, you use shared resources. Rapid elasticity, if you need more resources, you can get them. And it should be measured service, you can pay for what you use, or there is a little bit gray area where you can make it up. There are 3 different kinds of service models, which are software as a service, platform as a service, and infrastructure as a service. And the deployment models we can just see from. So let's take a closer look at the definition of platform as a service. It's a mouthful, but it's kind of accurate. So I just want to read it out. So platform as a service is the capability provided to the consumer is to deploy onto the cloud infrastructure, consumer-created or acquired applications, created using programming languages, libraries, services, and tools supported by the provider. So you can do whatever you want, you can do whatever the providers give you. This capability does not necessarily preclude the use of compatible programming languages, libraries, services, and tools from other sources. So it's not given that you can move to just a different provider. It's not standardized. So you buy into software. The consumer does not manage or control the underlying cloud infrastructure, including network servers, operating systems, or storage, but has control over the deployed applications and possibly configuration settings for the application hosting environment. So it's all about applications. It's not about servers. It's not about network. It's not about infrastructure. In my own words, I would say platform as a service is a self-service system which engineers can use to deploy microservice, specify configuration, start software, start apps, scale apps, forward logs or logging system without needing to care how or when. And this is really all I have to say about platform. So Cloud Foundry is such a platform as a service offering. It's open source. It's heavily used by the industry and it's backed by really, really big companies. So basically this first row here, they're all developing Foundry together. So Cisco is paying people to do this, Dell, IBM. And at least for them, I know that it's quite a lot. I think they have like more than 200, 300 people just working on this thing. Tipico, SAP, SUSE, and VMware. And all these other folks are contributing as well, not that heavily, but they're all using it. So Cloud Foundry itself says, in traditional IT, you manage the whole stack. The gears, gives you a little bit more, and you have to do less. And with the platform, you just care about applications and your data, and the rest is on it. So there's this wonderful quote from Onsi Fakuri, who is Vice President at Tipico. And he says, here's my source code, run it on the cloud for me, I do not care how. This is really how you should think as a developer using Platform-as-a-Service. You don't care on which service it's actually running. As long as it's running, you should do it. So Cloud Foundry is basically this huge white box, which gives you the front end, which we call the cloud controller, which we use for managing our apps. We can push our app, and then it runs somewhere in Cloud Foundry. Then Cloud Foundry has a router, and your users can use that router to get access to that application, to expose whatever this application wants to expose. And then we're sitting down here using Bosch, managing the Cloud Foundry. So it's not a layer on a layer on a layer, it's more like Bosch is instrumenting our cloud infrastructure to deploy new versions of Cloud Foundry, to scale out, scale in, all kinds of things. So the next byte, basically, what happens really in Cloud Foundry is you as a developer, you can provide a cloud controller in your application, probably as a jar if you really into Java, but you also have support for other languages. Then the platform turns that jar file into a container, because the platform doesn't really want to care about your application specific, so you have this process only once. You convert it into a container, and then we install the container blob store, and then we use that container image to create containers somewhere on the infrastructure, then we hook it up. And then we expose it via the router. And since the router is part of the platform, the router always has a table knowing, okay, I have a URL here, which is being mapped to these whatever how many instances you have. So all in all, Cloud Foundry doesn't do much. The main use cases are really deploying an application, configuring an application, start, stop, restart, scale applications, stream application logs, and connect to application via SSH. But then on the other side, this is really almost all of operations. I mean, there's logging and monitoring, but then you're good to go. If your responsibility is not the infrastructure itself, if you just care about the software. Cloud Foundry also, I was talking about Team A should not influence Team B, and Cloud Foundry isolates users. You can use authentication and authorization based on role-based authorization control. It integrates with LDAP and SAML. So, for instance, we have it running, we have it hooked up to our Active Directory server, so we just use our email address passwords that we use everywhere in the company. The users can only manage the apps they have access to. So you can say, like, okay, you can use your microservice and other people use their microservices. And we also have coders to control the maximum resource consumptions. Not like, this one team goes ahead and just eats it up all of it. And on the same side, we also want to have some isolation of the applications. And since every application is running within a container, this is one level of isolation, but we can also set up isolation segments to say, I probably don't want to use the same execution resources for my production that I want to use on my stage. All right, I hope this is big enough. This is a demo video. It takes about 2 minutes. So we have a microservice here, which I already compiled using Maven. It's a jar file, and you don't need to see the details really. I have a manifest here, which defines the name, how many instances, how it's 512 megabytes of memory. It specifies the URL and some configuration value. And now I do cf push, provide the jar file, and then off it goes. Uploads the jar file, turns it into a container using a build pack, and then stores this container, which we call a droplet, into a blob store, and from there we put it somewhere on a cell, which executes an application, and it does that 3 times, because I wanted to have 3 instances. And then the router exposes the URL, which is then going to these 3 instances, and I have automatic load balancing. And I can talk really fast. Okay, now the application is up and running. You can see that we have application hello, we have this URL, we have 3 instances, and now I'm just streaming the log so we can get an idea what's happening. I write a small loop, do 100 requests via curl, and since this is Java, the first request have to compile the servlet, and then it's really fast. So if I type this into sort unique, then you can see there are 3 different view IDs, which are randomly generated upon initialization, just to point out that we have 3 instances here, and this is really transparent to you. I just set up a little monitoring here, SSH into the container over there, identify my application, and just kill it, and you can see what's happening here. Cloud Foundry is automatically monitoring all the applications, all the containers, and is restarting the container if it falls down. So if you like this typical ops job of, oh, the application is not running, we need to restart it, is automated. And you don't have to care about that. All right. So the heart of Cloud Foundry is called Diego, which is a pun, really. The previous engine was called DEA, which was droplet execution agents. And they, which was written in Ruby, and they didn't like that, so they wrote it in Go. So it's D, like DA, in Go, Diego. So over here we have the Diego cluster. There's the BBS, the bulletin board system, which represents the real-time cluster state, and everybody is talking to this BBS. And it's regularly checking against the desired state. You can tell the cloud controller to say, okay, I want to have more instances, I want to have 5 instances, and BBS says, oh, I only have 3, so I need to react. And then BBS tells the brain to create 2 more instances. The brain holds an auction with all the cells, and then they decide who gets to run these new applications, also depending on how many resources do we need, how many resources do they have, all that kind of stuff. And the cells, they're really stupid. They just run tasks and non-running processes, and then they do a bit of deploying. All right, so to summarize what Cloud Foundry does, you have a router which automatically distributes load, and you cannot create an application without this router. So even when you have just 1 instance, you're still going through the router. Diego runs your containers and keeps them running. You can define custom health checks. I was just using the port. So Cloud Foundry is regularly sending a request to that port as long as you can establish a TCP connection. We assume that it's up and running. If you just have sort of a worker process, which is listening on a message queue or something like that, where you don't have a URL to access this thing, then it makes sense to monitor the process itself. If you want to get really fancy, I suggest you use HTTP health checks. So we offers these build packs to turn code into containers. There are default implementations for Java, Golang, Ruby, Python, Nginx, even .NET for Windows. PHP and Node.js, you can, this build is an open interface. You can write your own if you like. And the community did so you can also just pick it up from the community. You can even just tell Cloud Foundry where to pick this community build pack from. So you don't need to download it and push it again. You can just, okay, go to the internet and fetch it. Also, you can hook it up to a Docker trusted registry and run Docker containers. One other cool feature that I did not demonstrate is forwarding logs to an L. So you saw that we attached to our cell or our console to the logs of the application, and we can just tell Cloud Foundry the URL or the endpoint and user and password of our L cluster, and then Cloud Foundry just ships it off there and It's really simple to set up, and then you can just find the logs there, where you can probably search it, because dealing with consoles is rather inconvenient. With these routes on the router and being able to push applications and being able to map a route to an app, and also mapping one route to several apps and several apps having several routes, this allows us to do zero downtime deployments. So the first strategy that I want to show is called blue-green deployment. The idea is basically we have an application here in the backend, which is designated blue. We have the CI router, and there's a URL example myCI for that. And then we can create a secondary application which is completely independent. It might just be the same artifact with different configuration, or it might be a different artifact altogether. And then we can just define example test myCI for that. So we can check it out in production if it's up and running, if it's fine, depending on the application, of course, if it's doing something in the backend, that's great. Then we can assign the very same URL here, which leads the CI router to send some requests to blue, some to green, some to blue, some to green, some to blue. And then we can just kill this, and then all the requests end up in green. And there was no point in time where the router did not know where to send traffic. And you always get a response from somebody at least. And then you can remove the testing route, and then you have achieved the zero downtime deployment. There is another strategy which is called either canary deployment or rolling deployment. And the idea is that you just put out not the entire application, but just one instance. And you see, you pick it up into the load balancer, and from there it's just you just start monitoring to see how it goes. And if your monitoring indicates the application is healthy, then you go ahead to deploy all the other things. So in Cloud Foundry, it kind of looks like you have the application with 3 instances, you create a new independent application with 1 instance, you add the target route to the new app, and then you use scaling mechanisms to do this. And it kind of looks like this. In version 1, you add 1 instance of version 2, then you remove 1 instance here, add it there, remove here, add it here, until you can clean up, and then you have achieved your zero downtime deployment as well, but maybe you feel more comfortable with this. So for all this to work, you have to comply with 12 factors. There is a website called 12 factors, 12factor.net, which was created by the people working on Heroku, which was sort of the first platform as a service back then in 2007. Heroku was meanwhile acquired by Salesforce. So they give you some guidelines on how you should do things. One code base and stuff like that, that's kind of obvious. You should store your configuration in the environment variables. You should use processes. You should use processes also for concurrency. You should configure port binding. You should not assume like, okay, I'm always running on 8080 or something. You should, ask for, okay, what is my port? Because then we thought we can, put you in a container, put you somewhere, and then take care of all of that work, and your application just has to play along. Right, but the most important thing is apps must be stateless. If you need state, you need a persistent backend service, because otherwise this whole load balancer thing doesn't really work. And if you're really running things with just one instance, you're not running an HA configuration, and in the cloud world, the machine can go away at any point in time. So it's not really a good thing to do. So for backend service, Cloud Foundry implements the Open Service Broker API. Well, actually, they implemented the Service Broker API, and then they started to make that an official standard. So this is really the way how you integrate databases, message queues, caches, and stuff like that. The idea is the user can create a service instance via the platform, so talking to the platform, then the platform talks to other systems to make that happen. And then you can bind the service instance to an application, which gives you like, okay, I have my application, and I wanted to talk to the database. And you express that with the Cloud Foundry command. And then what the Cloud Foundry does is it takes the configuration and injects it into the application's environment. And then you can use a library in your application which knows that, and then it reads the application environment, and then for you it's seamless. you just say like, you know, library plugin. You never saw the credentials, and it's really nice. So like from an architectural perspective, it kind of looks like this. You have the API, which then talks to brokers. This is the service broker API, and this can run on anything. This can run on AWS, this can run on Kubernetes, or something else, whatever you like. And the responsibility of the broker is to do whatever it takes to create this new idea of this service instance. And in MySQL, it may be you spawn a new server, or you just create a new schema in an existing server, something like that. So for different, backend services, this can be different things. All right. So the last thing I want to talk about is BOSH. BOSH is again hiding down here, and it's our tool which we use to manage Cloud Foundry. When we talk about BOSH, we have to talk about release engineering. Release engineering, according to one of the release engineers at Google, is the difference between manufacturing software in small teams or startups and manufacturing software in an industrial way that is repeatable, gives repeatable results, and scales well. So, more formally speaking, it's about identifiability, reproducibility, consistency, and agility. And BOSH gives us all of that. In the BOSH world, we have three different things, well, three important things. First one is a stem cell. It's really the idea of we have a stem cell like our bodies, which we can turn into everything. And it really is a version operating system image bred with ES-specific packaging. So in our case, we're using AWS. So we just fetch the AWS stem cell, which is based on Ubuntu something, and it already has all the things that makes it run well on AWS. If you want to use Google Cloud, you just fetch the stem cell from Google Cloud. Then we have a release. This is really Cloud Foundry. So Cloud Foundry gives us this packaging for BOSH, which includes the binaries, configuration files, and whatnot. And then we can use that to create or specify how we want our Cloud Foundry to be set up. And then we can combine the stem cell with the release to create a deployment. And BOSH combines that for us and just puts it onto AWS. BOSH has this CPI here, the cloud provider interface, which you have different implementations. So you can go to AWS, you can go to Google Cloud, you can go to VMware, OpenStack, whatever you have. You just need sort of this API thing. So you can't go to bare metal because bare metal is not really responding well to API calls. But other than that, it really abstracts this ES for you. So you don't really care anymore. BOSH itself has also some health monitor and also where you can upload these releases and stem cells and such. NUTS as a message queue for internal communication or message bus. The registry monitors the virtual machines. So in Cloud Foundry, there is part of the stem cell is an agent for BOSH. So when some component in Cloud Foundry goes away for whatever reason, because Amazon decided to do away with this VM, then BOSH realizes that, checks against its desired state, and then just redeploys yet another one and connects it to whatever. So that's really nice. That we have the same thing that we have for Cloud Foundry, or the apps have with Cloud Foundry, we have with Cloud Foundry. All right, so as a summary, we talked a bit about the why. As a service suggests that focusing on core business through outsourcing is nice. Microservices increase operational complexity. DevOps requires a self-service system, which all lead to Platform-as-a-Service. Spoke about the definition of it with this special publication. And then we talked about Cloud Foundry and BOSH. Again, in my words, Platform-as-a-Service is a self-service system which engineers, and this is also important, the customers are engineers. I'm not I do not really care about our sports betting customers. My primary customer is the engineer that is caring about these sport betting customers. Of course, I'm an employee of this company, so I am interested in their satisfaction. But focusing on this is really anything. They can use it to deploy microservice specified configuration, as we have seen in the demo. We can start apps. It does it also for you if anything goes down. You can scale instances and you can hold up the running system. And you can do it whenever you want. So we can turn our organization from people talking to people because they want you to do, you want other people to do something for you. We can turn that into people talking to self-service systems which are maintained by other people. So of course, if you need a new feature or something, then of course you need to talk to people and share, your experience, and all of that is cool. But people do not become a bottleneck anymore in this scales from an organizational perspective. And here at BOOXWARE, we do this because we believe that engineering teams ought to bring features into production at their pace, be responsible for their product end-to-end, and be in control of their workflow. So it's really powerful people, kind of. And with this, I want to open it up to Q&A. Questions?
Maybe you can tell about something about Bosch Lite for small test environment for developers.
Okay. So I just repeat the question for the audience. The question is whether or not I can tell a little bit about Bosch Lite. The answer is yes. Bosch Lite is a really small setup for trying out Bosch. It's basically running new virtual box, and it's not using tons and tons of VMs, but it's using containers instead. But it kind of has the same feeling. You can set it up with the virtual box, which provides an API, and then you have a CPI for the virtual box interface. And then it feels really good. It takes a while to set up, I think like 2 hours or something. But if you follow the documentation, it really works. I did it. And then you can basically have a Cloud Foundry on your laptop, which is really nice. Obviously, connectivity-wise, it's less than ideal, but if you just want to play around with that experience, gain first experience is really good. Is that okay, or do you want to know anything specific?
If you want to try Cloud Foundry, you have no chance. You can't pay for AWS or something like that.
Well, you can. I mean, I showed all these. So the question was, if you want to try it out, you can't do it because then you have to pay a lot of money. But what you can do is go to any of the platform providers. So we're doing this, for real, and they usually give you a test account for 30 days or something, which is also good. So you can go to IBM Lumix, play around, and then create a new email address, and go there again. And if it's just about if it's just about trying things out, you can go to the big players and you get the test account for 30 days. That's really easy. If you want to get into the guts, then you should probably deploy it on your
You said that Diego can unlock languages. Does Diego use Docker on the or is it just the same
So the question was that Diego is able to run Docker packages and how this actually works. So Diego, the executor inside the cell has various things, various components, various layers. The further you go to the front end, the more abstract it is, and the further you go to the back end, the more specific it is. And we also saw that there are .NET applications which are running on, not Linux. So the back end there's a Linux back end, there's a Windows back end, and there's also a Docker back end. So it's real Docker. It's not, it's just pulling it through. It fetches the Docker image from your repository, putting that into the blob store. So it uses that same infrastructure to for all these generic things, but in the end, it's real Docker.
I thought it is Docker, and the Docker container is converted to Docker container. The Cloud Foundry uses Docker. But the Docker uses, because I'm developing for a microservice in .NET, but in .NET Core, and .NET Core runs native on Linux. Because we say that's .NET on a Windows machine. I push my apps to the Cloud Foundry with .NET Core.
Okay. So we are only running Linux, and we're not running .NET. So all my knowledge is based from things I catch up somewhere else, which is mainly from the Docker, not the Docker, but the beginning presentation from Tipico. And this was, I don't know, a year ago. Things might have changed because development in Docker is really fast. So maybe I was wrong about that, and .NET is really running on
It's .NET Core, but I thought it's Dart, the container.
Dart is the container technology they use for all kind of apps. But, well, how about we look it up and we'll post the answer on the meetup page, probably. Fair enough? More questions? Yeah, well, we'll be around quite a while. My team is sitting over there. You can say this thing. So if you want to know anything, you can talk to me, you can talk to them. And also, like, here, some certain people you can ask for directions with Cloud Finance. You forget how to apply. All right, then thank you very much and enjoy the beer.